Firefighters should know the purpose and location of each tool. Other fire departments and emergency agencies have additional fire suppression equipment you can call on when needed. Make a list of other resources and post it where you can get access quickly in an emergency. Fire suppression tools and equipment present many hazards. They should only be used by trained and qualified operators wearing protective equipment and clothing. They should never be operated by firefighters who are excessively fatigued. Firefighters should perform routine scheduled inspections of tools and equipment to ensure that they are in good working order and service to proper levels. Differently equipped response vehicles are used to suppress fires for various types and sizes of aircraft. Every ARFF vehicle is equipped with two-way radio systems to communicate with other ARFF vehicles, air traffic control, and other fire stations. ARFF vehicles have flashing or rotating beacons and are painted to contrast with the background environment. ARFF vehicles are equipped with fixed large volume nozzles or turrets on the bumper and/or roof. Bumper turrets are typically used at close range and to protect the vehicle from flare-ups or reflashes. The maximum range of a bumper turret without wind is usually 150 feet. A high-flow bumper turret is often the primary fighter-fighting turret. Most ARFF vehicles can discharge agent from turrets while moving. Many turrets have half-flow and full-flow settings, which allow firefighters to knock down a fire while conserving agent for later use. Bumper and roof turrets can have 4 different types of nozzles: air aspirating foam nozzles, non-air aspirating fog nozzles, chemical injection nozzles, and secondary agent nozzles. A non-air aspirating fog nozzle provides greater reach and stream distance than an aspirating nozzle. It also provides a protective wide fog setting for high radiated heat situations. In some instances, it may be quicker to extinguish a fire with non-aspirating nozzles than with conventional low expansion devices. There are fewer air bubbles in foam, so it is denser than aerated foams. This allows the foam to better penetrate the fire's thermal updraft or chimney effect and produce aqueous film faster. Truck-mounted and handheld piercing nozzles can be used to inject water, foam, and complementary agents through the skin of an aircraft. There are also a number of complementary agent nozzles that can be mounted on handlines, roof turrets, or bumper turrets. A twin-agent handline nozzle provides the option to use foam, dry chemicals, or a combination of both from a single nozzle. Federal Aviation Regulation Part 139 requires that ARFF vehicles carry twice the foam concentrate needed for the amount of water carried, or enough for 2 tanks of water. ARFF vehicles are manufactured in specific sizes to meet index requirements. Forward-looking infrared, or FLIR, cameras provide infrared guidance during low visibility response situations. FLIR images of an aircraft can help us identify normal heat signatures as compared to hotspots. Handheld thermal imagers are valuable tools during interior fire attack and search and rescue. The Driver's Enhanced Vision System, or DEVS, uses FLIR and other technologies to help drivers with 3 difficult aspects of poor visibility response: navigating to the accident site, locating the accident, and negotiating terrain and obstacles on the way to the accident site. DEVS can be implemented as a standalone system on an ARFF vehicle with no tracking or communication capability, or as a fully integrated system with an emergency command center. The DEVS navigation system provides the ARFF vehicle driver with the vehicle's location and helps navigate to the accident site. The tracking system helps the driver locate and navigate to the accident site. This capability will reduce driver communication workload and improve the situational awareness of the driver and command or dispatch personnel. The DEVS Low Visibility Enhanced Vision System uses FLIR or a comparable low visibility enhanced vision technology to improve visual awareness in smoky, foggy, or dark environments. Lifting devices, or airbags, as they are commonly called, are available for special operations at accident sites. These bags can generally be used anywhere there is a need to lift large or heavy objects. Other equipment includes devices to shore up damaged areas or spread or cut through difficult material, in addition to stabilization kits, collapse and containment kits, and expandable struts. Firefighters should make themselves familiar with the equipment available. ARFF vehicles are specially designed for airport firefighting. They are complicated to drive and require a high level of skill to operate. Firefighters must be properly trained in their use and operation and be able to demonstrate proficiency in the skill sets required to safely and efficiently operate the vehicle and all equipment. Improper operation can result in unnecessary damage to the vehicle or firefighting components, injury to personnel, and hampered response efforts. Hand lines are used to extinguish small fires that are inaccessible to turrets or for the application of complementary agents. A hand line may have to be moved around wreckage, across uneven and slippery terrain, and extended via ladders into the aircraft. The longer and larger the hose, the harder it will be to deploy and maneuver. Most fire departments require 2 personnel for a 1 3/4 inch hose. If your organization is operating with minimum numbers of personnel, you may want to use the lighter and easier 1 1/2 inch hose. Airports serving larger jet aircraft may want to use pre-connected hand lines of 200 feet or longer to reach most areas of the incident scene and aircraft. Most pre-connect discharge valves on ARFF vehicles are manually operated. These are valves that can be remotely operated from the apparatus cab or automatically opened when the hose line is pulled taut. Additional hose bundles or packs can be carried to extend existing lines or connect to apparatus structural panel discharge outlets. Enough 2 1/2 inch, 3 inch, or larger hose should be carried for water resupply. Small fire situations that do not warrant the use of turrets or hose lines should be handled with portable extinguishers. The NFPA recommends a minimum of 2 approved portable fire extinguishers on ARFF vehicles. There are handheld extinguishers for all 4 classes of fire, A, B, C, and D. They are usually pressure or cartridge operated. Water extinguishers are good for Class A fires. A Class A foam concentrate discharge tip can be added to make water extinguishers more effective on Class A and B fires. Almost every ARFF vehicle will have some type of dry chemical extinguisher, but ABC-rated dry chemical is not recommended for aircraft fires because it has a messy Class A extinguishing mechanism. Dry chemicals can also be abrasive and corrosive and can contaminate expensive aircraft avionics. ARFF vehicles should also carry some type of non-conducive clean agent extinguisher, such as Halon 1211, Halitron 1, or carbon dioxide agent. ARFF apparatus should also carry some type of Class D portable extinguisher to put out combustible metals, such as magnesium and titanium. Aircraft parking and hangar areas will often have large wheeled extinguishers available. Consider using these systems before discharging a vehicle-mounted system. Inspection of portable fire extinguishers should be part of regular maintenance. The extinguisher pin or actuator should have an intact lead wire or plastic seal. Look for any obvious damage or abnormalities when inspecting handheld equipment. Read the label to make sure it is the appropriate extinguisher for the fire situation. ARFF vehicles carry large quantities of water, foam concentrate, and complementary agents. Foam tanks are sized to carry sufficient quantities of foam concentrate to supply the ARFF vehicle through the discharge of at least 2 full tanks of water. ARFF departments and mutual aid departments must have compatible hose connections or proper adapters available. Make sure the correct type of foam is being added to the tank. All Part 139 airports should be using mil-spec 3 or 6% AFFF foam as their resupply agent. ARFF vehicles are calibrated and tested to deliver foam at the proper proportion for either 3 or 6% concentrates to ensure quality and consistency of the agent. Foam can be added to the tank through top fill or bottom fill connections. Every certificated airport will have at least 1 vehicle equipped with a complementary agent, such as dry chemical powder, Halon 1211, or Halitron 1. If the pop-up service indicator on the top of your dry chemical storage vessel is activated, it means that the system is pressurized or was pressurized and needs to be reserviced. As a general rule of thumb, cylinder pressure of 17 to 1800 psi is required for the proper operation of vehicle complementary agent systems.